Spice math. That's right. You add it up, multiply it, man. Spice math. Okay. A couple things we're gonna learn today. Spice math. All right. Take some time, educate yourself. Spice math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Erin Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hello once again, welcome back to Spice Math. Today we are looking at indices. And another word for indices is powers, or you can also use exponents. So we're going to put those up for you so you can take a note for it. Indices, powers, exponents. In today's lesson, you will learn how to define what is an index, and you'll also learn what happens when you multiply quantities that have some similarities together. Okay? So let's look at what an index is. An index is the amount of times a particular quantity is repeatedly multiplied by itself. That's basically it. So once you take one thing and you keep multiplying it by itself, then you begin to define what really is an index or a power. So if we take the number 8, for example, and we multiply it by itself 3 times. 8 times 8 times 8. Notice we're multiplying the number 8 by itself. That gives rise to the idea of indices or powers. This now can be written as 8, which is the number we're multiplying by itself. And in this case, we multiplied it 3 times. So we can say 8 to the power of 3, or 8 index 3. Or you can also say 8 exponent 3. But we're going to stick to the word power. So notice the 8 is a bit bigger than the 3, which is the power. And we want to give specific reference to this so that when you write in powers, you would know how to distinguish between the quantity that was multiplied by itself and the number of times that quantity was multiplied by itself. Let's take another one. What about A multiplied by A? Remember, we're talking about quantities being multiplied by themselves. That's what the idea of a power is. When you take one quantity and you repeatedly multiply it by itself. That's how you get the idea of the power. So A times A, how many times did we multiply? Well, it was multiplied by itself twice, so that gives rise to A to the power of 2. And this one has a special name. Anytime a quantity is multiplied by itself 2 times, it's called squared. So this is A squared. And interestingly, anytime a quantity is multiplied by itself 3 times, as we did in the first example, it also has a special name. It is called cubed. So those two are quite special. Squared quantities and cubed quantities. So far, we're going to leave the names of the others for the time being, and we're going to stick with those that are squared and that are cubed. So if we have a quantity raised to the power of 5, we would have to say it x to the power of 5 or 9 to the power of 5. Okay? Because the power of 5 does not really have a specific name. Now, we're going to do a short exercise. You will write down the examples and put it on the board, and you will express them as a power for me. Good. So you should have your answers ready. 5 times 5 times 5. What did you get? 5 cubed. That's correct. 2 times 2 times 2 times 2 times 2. That's how many? 2 to the power of 5. And the last one, z to the power of 4. So we see we can use the idea of powers to take a long expression of repeated multiplication and write it using two numbers or two quantities. Let's use the second one. Z to the power of 4. Observe the difference in size once again, because we're going to give them names. The smaller number to the top and to the right side of the bigger number is called the power, or the index, or the exponent. They all mean the same in this lesson. And the bigger number, the quantity which we repeatedly going to multiply by itself, is given a special name. It's called the base. Very good. So, we see that when a number is raised to a power, the quantity that is multiplied by itself a certain number of times is called the base. And the amount of times it is multiplied by itself is called the power. But I'd like you to observe the difference in the font size between base, which is usually a bigger font size, and power, which is usually a smaller font size, and off to the right-hand side of the base. So it's important for you to observe that. Anytime you write in a number to a particular power, the base has to be bigger in size, not in number, but in size. The power has to be smaller in size, or we can call it font size. So, z to the power of 4, the 4 is the power, it's written in a smaller font. The z is the base, it's written in a bigger font. Okay? Now let's experiment with what happens if you multiply quantities in the same base. So as we started with z, let's suppose we had this. Okay, so we're multiplying quantities. The base is the same, but the power is different. Z squared multiplied by z cubed. You remember those names? to the power of 2 means squared, to the power of 3 means cubed. Now let's expand it and see what they actually mean. Z squared multiplied by Z cubed. What does that mean? It means Z multiplied by itself twice, multiplied by Z by itself 3 times, because the power tells us how many times to multiply the quantity by itself. Z by Z by Z. What does that give us? If we take this expression here and we contract it back to a power, how many times is Z actually multiplied by itself in this expression? Z by Z by Z by Z by Z would give us Z to the power of 5. We see a very interesting thing coming up here because it's going to work out nicely even with other bases and other powers. Once the base, the one in the larger font, is the same when you're multiplying, did you notice what happened? We can simply add the powers. 2 plus 3. We're not adding the bases, we're adding the powers. But that addition can only take place on condition that it's the same base you're multiplying by. I wonder if that would happen with different powers. Let's see. This time we're going to put a number in. 7 to the power of 4 multiplied by 7 to the power of 6. Again, the bases are the same and we multiply. What do you think would happen? Yes, you got it. We would get 7 to the power of 10. And that is 4 plus 6. Now that leads us to one of the rules that governs indices or powers. And we're going to look at that rule and see if we can commit it to memory. Very well. So this is the statement. And that statement came from the 2 examples we just did, where we multiplied 2 quantities with the same base. And the statement says, when multiplying quantities with the same base, you add the powers. And we'll consider this as rule number 1 that governs the concept of powers. Okay, let's see if we can say it. We can say it together. When multiplying quantities with the same base, you add the powers. Now there's a little activity I'm going to give to you to see if you can apply this rule. So now you should have completed the little exercise we had. M to the power of 6 times m to the power of 5, and so on. And we want to apply the rule that we expressed just now. The one that said when you multiply quantities with the same base, you've got to add the powers. Let's see if it applies here. M to the 6 times m to the 5. The answer should be m to the 11. 3 to the 5 times 3 to the 9. That actually gives me 3 to the 14. That's the answer. Number 3. Z to the 9 times z cubed times z should give me z to the 13. And number 4, same base, 11 to the 6th power. In case you're wondering, when a quantity is written without any power, it's understood to be a 1. Okay? Anytime a quantity is written and there is no power written, the power there is understood to be 1. So this is here 11 to the power of 1. So 2 plus 3 is 5 and 1, 11 to the 6. And number 5, 2 to the power of 5 multiplied by 5 to the power of 7. Can we apply the rule here? Are the numbers in the same base? Well, sadly, they are not in the same base. So the rule for indices cannot apply here. This would have to remain 2 to the power of 5 multiplied by 5 to the power of 7. It cannot be simplified any further. So in today's lesson, you learned that we can use 3 words to refer to a power, and that's the word power, the word index, and the word exponent. You also learned that when you write in numbers or quantities that are multiplied by themselves repeatedly, you have to write the base in a bigger font than the power, which is written in a smaller font and at the top of the number. We also learned that if you're multiplying quantities with the same base, you can simply keep the base and add the powers. And that rule is going to come in very handy when you have to work very long expressions in indices. We're hoping that in our next lesson, we're going to look at some of the other rules in indices. We will leave an activity for you to practice with, and I hope to see you next time. Have a good time.
Take some time, educate yourself. Spice math, that's right. You won't believe it's just math. Come on. You won't believe it's just math. You won't believe it's just math. Just math. Spice math, that's right. You add it up, multiply it, man. Spice math. A couple things we're gonna learn today. Spice math, alright. Take some time, educate yourself. Spice math, that's right. You won't believe it's just math. Come on. You won't believe it's just math.